Your first request to a new domain is always the slowest, not because the server's busy, but because of a hidden three-way handshake that can eat over 100 milliseconds before a single byte of application data moves. Every time you hit a new host, your browser must resolve the domain name, open a TCP connection, and negotiate a TLS session. That fixed overhead can dominate the total time for a small request, even on a fast network. Let's walk through each layer and see why. TCP starts with a three-way handshake. The client picks an initial sequence number and sends a SYN packet. The server replies with SYN ACK, acknowledging the client's number and offering its own. The client then sends an ACK, and only then can it send data. That exchange takes exactly one round-trip time between client and server. For a typical 50 millisecond RTT, you're 50 milliseconds in before you even think about encryption. Now add TLS in version 1.2 after TCP is established. The client sends a client hello with supported cipher suites. The server responds with its certificate, chosen cipher, and server hello done. The client must then verify the certificate and send its key exchange material, signaled by a change cipher spec record. The server finally completes the handshake with its own finished message. That's 2 more round trips on top of the TCP cost. TLS 1.3 crunches this to a single extra round trip. The client already includes its Diffie-Hellman key share in the initial hello. The server, upon receiving it, can compute the session key immediately and respond with its own key share, encrypted extensions, and finished message, all in one flight. The client acknowledges with its own finished, and application data can follow. So with TLS 1.3, you pay 1 RTT for TCP and 1 for the handshake, cutting the setup time nearly in half. And there's yet another trick: 0 ORTT resumption. If the client has previously connected, it can send encrypted application data inside its very first TLS flight, completely eliminating the TLS handshake. The catch? Those 0 RTT data can be replayed by an attacker, so they must be idempotent. Fine for a cache get, dangerous for a payment. Still, for many workloads, it makes the second connection feel instant. So why is the first request always the slowest? Before you can even send an HTTP GET, you must pay DNS resolution, usually 20 to 100 milliseconds, then the TCP round trip, 1 RTT, then the TLS round trips. For a 50 millisecond RTT, that's DNS plus 100 milliseconds of pure handshake overhead. Only then does your request start traveling. That handful of extra frames is why opening a fresh connection to a new origin feels laggy. After that first request, Keep Alive steps in. Every modern HTTP client and browser reuses TCP connections. A connection pool hangs onto idle connections, so subsequent requests to the same host skip the TCP and TLS dances entirely. You pay the handshake once and amortize it over hundreds of requests. HTTP 2 and HTTP 3 push this further. HTTP 2 multiplexes dozens of streams over a single TLS session, so you don't need to open multiple connections to the same origin just to load a page's sub-resources. HTTP 3 runs on QUIC, which folds transport security directly into the initial handshake, supports 0 RTT, and eliminates head-of-line blocking. Edge cases matter. On a mobile network with a 200 millisecond RTT, a full TLS 1.2 handshake plus TCP can chew up 600 milliseconds before any data flows. In a microservice mesh, if 2 internal services don't reuse connections, every call pays TCP and mTLS, adding tens of milliseconds to each hop, quickly ballooning end-to-end latency. Trade-off: keeping connections alive forever wastes server resources. Each idle connection consumes a file descriptor and a few kilobytes of memory. Pick a keep alive timeout too short and you'll do fresh handshakes too often. Too long and your servers buckle under thousands of stale sockets. Real systems tune this based on request patterns and available headroom. Imagine a typical production setup. A load balancer terminates TLS, and an API server behind it queries a database. If that service opens a new TLS connection to the database for every query, no pooling, you add a complete handshake to every database call, With a 5 millisecond intra-data center RTT, that's still 10 extra milliseconds per query, enough to turn a 20 millisecond average into a 30 millisecond one. The fix: always keep persistent connection pools with health checks and proper idle timeout configuration. Rule of thumb: measure the handshake overhead for your own traffic. For user-facing services, pre-warm connections, and resolve DNS ahead of time. For internal services, enforce connection reuse and watch for mTLS overhead. Without that, your first request will always be the slowest, and your users will notice. To recap, the first request to any host pays a mandatory toll of DNS, TCP, and TLS handshakes. Those round trips multiply by geographic distance to create a latency floor. Use Keep Alive, connection pooling, TLS 1.3, and HTTP 3 to amortize that cost to near zero for subsequent requests. Understand the handshake dance, and your systems will be fast from the very first byte. Thanks for watching. I hope this one was useful. See you in the next video.